Hello friends, welcome you for the lecture series of engineering mechanics. Today we are going to solve some numericals of non-concurrent force system. So today we are going to solve the numericals to find out the beam reactions. So let's consider this problem. This beam is simply supported at point A where there is a hinge support, and at point B it is simply supported over the roller support. If you observe this particular beam, you found out that different varieties of loading this beam is subjected. This beam is subjected to UVL, this is point load, this is UDL, uniformly distributed load, and this one is your point load, inclined point load. So while solving this problem, you have to convert this UVL, that is uniformly varying load, into the point load, and this UDL you have to convert it into again point load, and this inclined load you have to find out its two orthogonal components. Okay, so how to convert this UVL into point load? We have to find out the area of triangle. So what is the area of triangle? 1/2 base into height. So particularly for this type of loading, the base is 3 meter and the height is 30 kilonewton per meter. So 1/2 base is 3 into 30, and it is acting always at a distance of L by 3 from the right angle side. So this right angle side is here and it is acting at a distance of L by 3. This 3 divided by 3, that is 1 meter from this end. So for your understanding, I will give the nomenclature to this: C, D, E, F, and this point is G. So it is acting at a distance of 1 meter from point C, or we can say that it is acting at a distance of 2, 3 from the 0 end, that is 2/3 of 3, that is 2 meter from end A. Okay, now this point load is acting at a point D, and this UDL, we have to convert this UDL into point load. So what is the intensity of loading? 20 kilonewton per meter is the intensity of loading, and it is acting over a span of 2 meter. So 20 into 2, that is 40. So I will write down here 40 kilonewton. So I have converted this UDL into point load, and it is acting at the mid span of this EF, that is 1 meter from the E, or we can say that 1 meter from the F. So the distance between D and this point load become 1 plus 1, 2 meter. Okay, now come towards this inclined point load. Now this inclined point load, we have to convert this inclined point load into its two component orthogonal components, or we have to resolve this 60 kilonewton force into two components, one in y direction and one in x direction. So x direction component, as this force is, if you observe that it is in third quadrant, so x is towards left and y is in downward direction. So 60 cos of 60 is the horizontal component of this force, and 60 sin of 60 is the vertical component of this inclined force. Now we have to replace this roller support by how many reactions? Yes, one reaction. Similarly, I have replaced here the hinge support by its two reactions in x direction as well as in y direction. Now this free body diagram is in front of you. Once the free body diagram is over, the next step is to apply the condition of equilibrium. So what are the conditions of equilibrium? There are the three conditions of equilibrium: summation of all the forces in x direction equal to 0, summation of all forces in y direction is equal to 0, and summation of moment of all the forces about any point is equal to 0. So these three are the condition of equilibrium. So apply the conditions one by one. First, summation of f of x is equal to 0, means summation of all forces in x direction we have to consider. Now for that, I have assumed the towards right is positive. So what are the forces in x direction? There is one force Ax and another force is 60 cos of 60. Ax towards right positive, 60 cos of 60 towards left negative. So plus Ax minus 60 cos of 60 is equal to 0. So you will get the value of Ax 30 kilonewton, and your answer is positive. So assume direction is correct. Now Next, summation of f of y is equal to 0 means summation of all forces in y direction we have to consider. So what are the forces in y direction? So excluding ax and the 60 cos of 60 here, all the forces in y direction. Okay, so let's begin with the ay. So ay is towards up, our sign convention is towards up is positive. So plus ay minus, so I have converted this UVL into point load. So what is that? 1/2 base into height. So 90 divided by 2, 45. So this is minus 45 minus 40. Then this UDL I have converted it into point load. So 20 into 2. So it is 40. So this is minus 40, again it is in downward direction. And this 60 sine of 60 comes out to be 51.96. It is minus y because it is again in downward direction, and this by is plus because it is in upward direction. So I have written the equation of summation of f of y and equate it to 0. Okay, once you solve this, you will get another equation having two unknowns, ay plus by is equal to 176.96. So here if you observe the equation of ax and ay plus by, that is summation of f of x and f of y, there are the three different unknowns. So we cannot able to solve this problem by using two equations. So we have to go for the third equation. What is the third equation? Yes, we have to take the equation of moment. So for that, either you have to choose the moment center anywhere on this beam. So always remember that where there is maximum number of unknowns, there you have to choose the moment center. For simplicity, I have choose the moment center A, and my sign is, I have considered if anti-clockwise moment is there, that is positive. If clockwise, then it is minus or negative. So moment about A equal to 0. So 45 into 2. This is 45. If you take the solve this, then you will get this point load 45 into perpendicular distance is 2 meters. So 45 into 2. Then next 40 into perpendicular distance between point D and A, 2 plus 3, 5 meters. So 40 into 5. Then again 40 into 7 minus, it is again all three are minus because it will all create the moment in clockwise sense. Then next 60 sine of 60, 60 sine of 60 having the moment again clockwise sense, so it is 51.96 into 9, and now comes towards this by. This by, if we take the moment about point A, so it will create the moment in anti-clockwise sense, therefore it is, yes, positive. Yes, very good. Then it is positive, so 10 by. So if you observe this equation, in this equation only unknown quantity is by. After solving this equation, you will get the value of by. That value of by is 103.76. Once the by is known to us, substitute this by in equation number 1. So you will get the value of ay. So now ay is known to us, by is known to us, and ax is known to us. Thus we are able to find out the support reactions. That is nothing but the reactions provided by the support. So this is our problem number 1. This is problem of parallel force system or non-concurrent parallel force system, or the beam reactions which carrying the different types of loading. So very simple problem is there. Now comes towards the problem number 2. First I will read out the statement for you. So what is the statement? A T-shaped bracket supports the 4 loads as shown. Determine the reaction at A and B if A is equal to 100 mm and A is equal to 70 mm. Now if you observe this figure, there is a T-shaped bracket. This bracket is of T shape which is supported at point, let's say this point, I will consider this point is moment about, let 1 minute, B and, yes, this is point B and this is point is A. Okay, this point is A and this point is B. I have forgot to write down here notation. So this point is A. Now if you observe that what happened, this bracket due to this loading will going in a downward direction. Therefore this part which is behind B, it will going in upward direction. Therefore support should be at point A is in downward direction. All of you getting or not? What is the direction of support that we have to be find out? Very simple. Or otherwise you can show the direction anywhere, and accordingly that you have to write down the its sign, upward or negative. And the distance is given 60 in between these two, 40 and 50, 60 in between 50 and 30 A, and 30 and 10 Newton is 80 mm. This value of A is given for first case 100 mm and for second case it is 70 mm. According to that you have to find out the support reaction at A and support reaction at B. At A there is we can say that there is a hinge support, and at B, if you observe this, the symbol is of roller support. So roller support offered one reaction and hinge support offer the two reactions. So according to that you have to draw the free body diagram. Okay. Now concentrate on this diagram. So in this diagram I have replaced this support B by its two reaction HB and VB, and this roller support by its one reaction, that is VA, which is in downward direction. Okay, so 10, 30, 50 and 40, these are the given loading, and the distance is given in between the loads is in front of you. So now once the free body diagram is over, now next step is to apply the condition of equilibrium. First condition is summation of f of x is equal to 0. So summation of all the forces in x direction, let's say that towards right is positive. I have assumed the direction. So how many forces in x direction? If you observe this figure, there is only one force in x direction, that is h of b. So h of b is equal to 0. Now second equation of equilibrium, summation of f of y is equal to 0. I assume towards a positive. So whatever the forces in vertically upward direction positive, whatever the forces in downward direction is negative. So VA minus VB is equal to 0. Here I have written in wrong manner also. Here VA I have written positive and VB is in negative. So you can change its sign convention also. Okay, according to that. Minus VA plus VB is equal to 0. Now from this equation we cannot able to get our answer. Sorry, minus VA plus VB is equal to not 0. So this is minus 40, minus 50, minus 30, minus 10, and then it is equal to 0. Sorry for that, I have forgotten to write down these terms. So minus 40, minus 50, minus 30, minus 10. So what is the summation of this? 50 plus 40, 90, 90 plus 40, 130. So you can write down this equation is again like that. I will write down here on the top. So V minus VA plus VB is equal to, if you take this on the right hand side, that is 130. Or we can write down therefore VB is equal to 130 plus VA. Okay. Now in this equation there VA and VB are unknowns, so we cannot able to find out the value of VA and VB by using the first one and second equation. Now for that we have to apply the third equation, that is condition of moment, and equate it to 0. So I have take the moment about point B and equate it to 0. So moment about point B, that is VA into 120 plus 40 into 60. So here the moment is in counterclockwise, therefore positive VA. So VA into 120, then 40 into 60. The sign is positive because it will create the moment in anti-clockwise sense. Then 30 into A, it will create the clockwise sense moment, therefore minus 30 into A. Then next 10 into 80 plus A, it will create the moment in clockwise sense, therefore it is minus 10 into 80 plus A, which is equal to 0. So after solving this you will get one equation, VA is equal to minus 33.A minus 13.33. Now here first condition, if A is equal to 100, it is mentioned over there, when A is equal to 100, we have to find out the value of VA. Substitute the value of A is equal to 100 in this equation, you will get the value of VA, that is 19.67 kilonewton. Now once VA is known to us, substitute this VA in this equation, so you will get the value of VB. That value of VB is 149.67. Please check that. 19 na? Yes, 149.67 kilonewton. Now VA and VB is known to us, then again HV is known to us, that is support reaction we have find out. Okay, so today we have solved the two numerical friends. Which are those? One is the beam reaction, to find out the support reaction of beam carrying the different types of loading, and one is of the bracket load or T-shaped beam. Here also we have find out the support reaction also. Sometimes in a problem support reactions are given, from that you have to find out this value of distance also. Okay, so thank you very much.